Hello. Earlier we have seen what is epsilon NFA. Now we'll see epsilon closure. So why it is required? Basically, as we know that deterministic finite automata and non-deterministic finite automata are same in a power. Means what? If I have a NFA, I can draw the DFA. If we have a DFA, we can convert it into NFA. And while doing so, we need epsilon closure. Because as we know, NFA means epsilon NFA also can be converted into DFA. While doing so, I need to know what is the epsilon transitions. So, or what are the closures? What is the epsilon closure? So today we will see that part. That means we epsilon close a state Q by following all the transitions out of Q that is or that are labeled as epsilon. However, when we get to other states by following epsilon, we follow the epsilon transition out of those states and so on. So eventually finding every state that can be reached from Q along any path whose R's are labeled as epsilon, right? That means whenever there is a direct path, that means suppose state 1 to state 2, in between there is an arc of epsilon, that means it is an epsilon closure. So let's see initial state. What is initially closure? That means start state. Basically at any individual state, suppose state Q is in eclosure Q. That means every state is reachable to itself on epsilon, or without consuming any energy I can switch to the same state, right? There is a always transition from that to state to the same state. That is the basis, right? Now with respect to other states, that means state 1 to 3, state 1 to 2, 2 to 3, or state 1 to other state, I say if state P is in eclosure Q, means what? There is a transition from state P to state R labeled as a epsilon. Then R is in the eclosure, right? That is a basic definition of eclosure. Now, more precisely, if delta is a transition function of epsilon NFA involved and P is in the eclosure. Eclosure we already see. P is in eclosure means what? P is eclosure already defined. There is a transition from P to state R labeled epsilon. Then R is in the eclosure. That means epsilon closure. Then epsilon closure of a Q also contain all the states in the delta transition from P to epsilon. Theoretically, if you don't understand, we will see practically. What do you mean by eclosure or epsilon closure? Theoretical things, that means here it might sounds quite difficult to understand. Let's say one example. Here, this is one of the example we already studied in the epsilon NFA. Same example I take here for better understanding. This is the epsilon NFA for representing a digital number followed by a decimal, or plus minus decimal number, plus minus digits, decimal point, and again digits. This is what the problem statement we already discussed. So here in this case, what is I just seeing the transition graph. May I conclude what are the eclosures? That means epsilon closures. That we have to identify there is a path from one state to other state on epsilon. That is the eclosure, simply. So eclosure of Q0 is the same state as itself as from the, I can say, first basis. This is the basic. That means for every state there is epsilon closure to the same state. That's why in this state Q0. And now see, here is a path from Q0 to Q1 on epsilon. So Q1 is also eclosure, right? That means eclosure of a Q is a set of Q0, Q1. In other words, I may say at a particular state Q0, On reading epsilon, I may go to the Q0 and Q1. Now, see other states, there is a path on Q5. So, what is the, or Q3, right? So, Q3 to Q5, there is a path on the epsilon closure. So, what I say, epsilon closure of a Q3 is equal to the same state Q3 and the next state where it goes on the epsilon, that is a Q5. So this is how epsilon closures are calculated. Now for better understanding, let's take one more example. This is also we have already discussed. Sorry, no, this is not discussed. This is just a transition graph, right? For just to calculate the epsilon closure. Now see states 1, 2, 3, 4, 5, 6, 7. These are the states. How many states? 7 states. Out of that, epsilon transitions are these many, right? 1 to 4, 1 to 2, then 2 to 3, and 3 to 6, 5 to 7. These are the epsilon closures. That means there exists a path on empty string epsilon. So eclosure for 1 is what? Eclosure on 1 means on I may go to the same state, right? So 1 is there. There is a direct path on epsilon from 1 to 2, so 2 is there. Then there is a path from 1 to 4, so 4 is there. Now why I wrote here 3 and 6? See, 1 to 2, 2 to 3, the epsilon, it again becomes epsilon. So there is a direct path from 1 to 3. Similarly, concatenation of epsilon, epsilon, epsilon again gives me the epsilon only. So that's why there is a epsilon closure from 1 to 6. So we included 3 and 6 as well. But see here, we can't include epsilon A, epsilon. No, this is 7 is not in the state, right? We can consider for fifth state, not for the 1 or 4, right? So epsilon closure of 1 is this one. Now extension, what is the epsilon closure? We'll see. We sometimes need to apply epsilon closure to the set of state S. We do so by taking union of epsilon closure of the individual states, right? That means epsilon closure of a S is union of all the states in a Q, union of all the states in S equals, right? So what it means, this is the equation. We can apply this practically. This is used for extended transition function. That means after reading a particular string, what will be the next state? There is no need to always switch from the first state to the accepting state. If I read part of the string, that means I'm at an intermediate state and I wanted to know what will be the next state, then extended transition function is used. So what it says, extended transition function of epsilon NFA, that means transition function Q epsilon at very first. What is output? E close Q. This is what we already seen. Now you will understood why we studied that E close. Why or how it is important, where it is used to find the extension or the extended transition function. Now suppose W is of the form XA, where A is the last symbol of the string W, such that A belongs to alphabet set and A should not be epsilon, because we already considered for the epsilon. Right now here what will be the states? So extended transition function at a state after reading some string X, it will give me the set of states P1 to Pk. Union of all the transition functions of that state on A we have to find out, right? That will give me some again number of states R1 to Rm. So finally extended function QW is equal to nothing but E close of R1 to Rm. And we know that E close of a particular state at a particular symbol, how to find it out, right? By using the same rule, we can generate the string. So for earlier example, the transition graph we have seen, take example or one string as a 5.6. If this is what string I have read, then what will be the next state? if I wanted to find out how you will go or how you will find it out, extended transition function Q0 on epsilon, very first state. Yeah, this is what initial condition. So this will give me the eclosure of a Q0. Any state on the epsilon is called as the epsilon closure. Epsilon closure of a Q0 is the same state as itself, and there is a transition from Q0 to Q1. If you don't remember, I will show you the diagram. See, Q0 on epsilon goes to the Q1, right? So this is our first equation. Fine. Now, similarly, we will find extended transition function at from start state. Always we have to find to the 5, then 5 point, and then 5.6. So by using the induction, any state, just now we have concluded that Q0 on 5, right? Q0 on 5 means what? Q0 on 5, Q1 on 5. Union, we need to find out the transition function because already we got this Q0 and Q1 as a set. So now what we have to consider? Q0 on 5 and Q1 on 5. What is the transition function? And then as there are the both condition, we have to take the, or we are supposed to take the union here. Fine. So Q0 transition on transition of Q0 on 5 union transition of Q1 on 5. That will give me, for your reference, this is the diagram. Q0 on 5 give me Q1, and Q1 on 5 again give me the Q1, right? So based on that, here Q1 on 5 is Q4. Q1 on 5 again it may be Q4, right? So I may consider Q1 as well, or Q4, as this is a epsilon NFA. NFA, as it is NFA, I may remain in the same state or I may switch the state. This is NFA, remember that, right? What NFA says, for a particular symbol there may be 0, 1 or more path. So in this case I may remain in the same state, or alternative I may go to the Q4. So this is what we have considered. We have to consider all the things. Already we considered Q1 on 5 is again a Q1, right? So we are not going to include it. It is already there. So Q1 on 5 there is another path, so called Q4. So we will get Q4, right? Now epsilon closure of Q1 and epsilon closure of a Q4 we have to find out, and we have to take the union of that, which will gives me Q1 union Q4. Remember that these are the states. So here what we got, epsilon closure of Q1 and Q4 is Q1 and Q4. Union of that we will get the set of state Q1, Q4. Now what we have to find? We have to find the 5 point, or that is 5 decimal point. So we have to find the transition function of 5 point on Q1 and Q4. The same state we repeat earlier did. We have to again repeat the same thing. That means now Q1 on dot and Q4 on dot, which will give me the Q2, Q3. Find out the closure, take the union of that, you will get Q2, Q3, Q5. Now on this I have to find the next symbol 6. So extended transition function of Q0 5.6 is nothing but, because 6 is the last symbol and we divide this string as a XA form, right? So X is now 5 point and A is 6, the last symbol read. Already we read till 50, and till 50 we got this Q2, Q3, Q5. Now find the transition functions of that, all the strings, take the union of that on 6. It means transition of Q2 on 6, transition of Q3 on 6 and Q5 on 6, and all union. So you will get output Q3 union 5, which gives me again Q3. Now take the closure. Closure of Q3 gives me Q3, Q5. So this is what your extended transition function. After reading the string 5.6, you are in the state Q3, Q5. Okay, so this is what extended transition function for today.